Have you ever wondered about what the biggest explosion in the whole universe is? This is all about supernovae. I ate a supernova. If you want to find out what that really means, stick around until the end of the video. It's boy time! The physics of dying stars. Stars survive by fusing hydrogen into helium to produce energy. So gravity wants to make the star collapse, right? But then this energy stops that. When the hydrogen runs out, the star starts collapsing because nothing balances out the gravity. The temperature goes up and helium starts fusing. The helium fusion produces so much energy that the star expands to hundreds of times its original size, becoming a red giant. While the helium core is fusing, a layer of hydrogen outside the core starts fusing. So this is the red giant, and if you look closely, you might be able to see a tiny dot, which is the size of the sun right now. So this cycle repeats. It keeps collapsing, then fusing, and then getting bigger until the newly made iron core, so iron can't really fuse that well, until that weighs more than 1.4 solar masses. When this happens, the core starts collapsing at up to 75,000 kilometers a second. 75,000 kilometers is this much. If this is the Earth, 75,000 kilometers is like this much. So, yeah. The explosion itself. While the iron core collapses, the protons and electrons are jammed together to make neutrons. When neutrons are jammed together, they produce an immense outward force that basically stops them from touching. Is that their way of social distancing? And it is this that stops the collapse. The incoming outer layers of the star bounce off to make a shockwave that eventually becomes the nebula. This is called a core collapse supernova, or the normal supernova. There's another type of supernova, the type 1A. That happens when there are two normal stars orbiting each other. The bigger one becomes a red giant, and then gas comes off it and spills onto the smaller star, making it get bigger and then become engulfed. The star and the small star and the core of the big star spiral towards each other inside a common envelope. The common envelope of gas goes away, and then they keep getting closer. The core of the giant star collapses and becomes a white dwarf. The aging companion becomes a giant, spilling gas onto the white dwarf. The white dwarf explodes. So, it explodes when the spilled gas makes the white dwarf start a runaway fusion reaction. Fusion, making heat, making more fusion, releasing enough energy to gravitationally unbind the particles. There are three types, all about nebulae. There are three types of nebula. Shell-like, because it looks like a shell. Composite was another type of nebula called a pulsar wind nebula. I know there are a lot of big words inside. And then thermal composite. So there's X-ray emission inside some radio emission shell. There are 5 stages of expansion. Free expansion until the nebula sweeps up its own weight, sweeping up shocked material, so the material properties changed because there's so much energy. Cooling of the shell of shocked material, cooling of the interior, and then merging with the surrounding material. That's like the death of the nebula, and it happens after about 30,000 years. So this is the Cloud Nebula. The supernova that created it was observed by Chinese astronomers in 1054 AD, and now, almost 1,000 years later, it's become a beautiful supernova. It's playtime! So, today I'm gonna be using Universe Sandbox. So, as the name suggests, it's a simulation that basically just lets you, so you can just put stuff in a simulation of the universe, and you can have lots of fun doing it. I assure you, deleting the sun and putting a 10 million solar mass black hole instead is fun, okay? So, I'm gonna show a supernova in Universe Sandbox. So, I'm gonna say how fast it is, because it's actually really fast and you have to see it. Otherwise, it just doesn't really work. So, and then, So I'm also going to show how hot it is. And also how beautiful it is. So I'm going to, Just a fair warning, the supernova, the sun would never actually go supernova. It doesn't weigh enough. So we have the sun here, and this is just the solar system. And so the sun is going to go supernova in 49.8 seconds, as it says here. So now I'm going to put it into real time. Oh, I guess 40 seconds. Anyway, I'm gonna just speed it up a bit so that we don't have to wait for long. So it's gonna go in I'm gonna do a countdown from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Kaboom! And it's already 2 times the size of the sun. I think that's a bug in the code. But anyway, you can see here how fast it's expanding. It doesn't really look like it's expanding so fast, but if you look at the speed bar, it's expanding at 1/10 of the speed of light, 30,000 kilometers a second. So if this is the Earth, 30,000 kilometers is this much? No, a bit more. Yeah, this much. So by the time I've said all of that, it's already 5 times the size of the sun. So that's how fast it expands. And this is actually a bit slower than real time. So now if we look at Earth, we can see the temperature hasn't changed because the supernova is still so tiny compared to Earth's orbit. But now, as I speed it up, you can see that the temperature will actually soon start going up. I'm just telling you. Hasn't gone up at all yet. Oh, now it's gone up. It's gone from 13.8 degrees to 13.9. That might not seem like much, but look, it looks like the outer reaches of the supernova still haven't reached Mercury's orbit. So isn't that cool? So I'm gonna speed it up a bit more. And fair warning, the temperature is about to go boom. So, and it hasn't reached Earth's orbit yet. You can see that. But it's now 14 degrees. Yeah, the temperature is gonna boom in like 5 seconds. So now the supernova has reached Earth's orbit, and the temperature is booming. It looks really fast, but actually it's not really so fast yet because I sped it up so much. But still, this is like over the course of an hour, the temperature has gotten like too hot for people to inhabit. So yeah, okay, that's enough. Oh my god, Earth is burning up. So now, back at the supernova. No, that's not the supernova. So this is the supernova, and it's like almost 7 times Earth's orbit. Okay, this isn't really real time yet, so you can't really see the expansion well. But let's just check the age of the supernova. 6 hours, and it's 8 times Earth's orbit. That is very fast. If we look in kilometers at the size, oh my. Wait, is that even all of it? Yeah, that is a lot. I'm just gonna go into real time and see how fast it's going in kilometers. That's thousands of kilometers, millions of kilometers a second. So yeah, it's like 10 Earths a second. Okay, so that's all the information I'm gonna give. Well, one more thing. Do you think that that's not very bright? You think that, don't you? I know that you think that. So now what I'm gonna do is add a galaxy, just plop the Milky Way here. Yeah, okay, that should be close enough. And now you can, so now you can already actually see it from Milky Way size, like scale. You know I mean scale. Oh, that's zoomed out way too much. So there we go. And if I speed it up a lot, you can just see that like a lot. Yeah. So the supernova by now, I'm just gonna check on it, and then that's enough. That should be enough. Oh, come on, pause. Yeah, okay, that is big. Yeah, that's really big. So yeah, that's about it for now. So that's enough explaining about supernovae. Did you really think that was big? That was humongous, right? Yeah. So, it is 10 under 10 time. First, I'm gonna tell you what I ate a supernova means. You thought I would tell you in the end, right? So you skipped to the end. But I'm gonna tell you now. So 8 is spelled A-T-E, right? 8, not the number. So A-T-E, you know what else it stands for? A stands for astronomical. T stands for transient, which means it comes and goes. And E stands for event. And a supernova is an astronomical transient event. It still doesn't make much sense, but... So 10 under 10. 1. The iron core collapses at up to 75,000 kilometers a second. 2. The nebula expands at up to 30,000 kilometers a second. 3. Red giants are hundreds of times bigger than normal stars. 4. There are 3 types of nebula. 5. Type 1a supernovae explode after a runaway fusion reaction. I just realized what else expands after a runaway fusion reaction. A nuclear bomb! Okay. 6. Unlike core collapse, exploding when a wave of material bounces off a neutron core. 7. Nebulae are visible even at galaxy scale. That's just crazy. 8. They are also extremely hot. 9. They expand to the size of the solar system in a day. I don't think I showed you that, but 10. they can live for 30,000 years. So, how big do you think they would get? That's my question for you. Let's see what our Magic Resources cabinet has cooked up for us today. Okay, so first, Wonders of the Universe. It's one of the best books about space, and it has the best metaphors ever. So one of the metaphors was like a supernova remnant nebula. Like it's sort of like this prison that he found, like the star about to collapse. It's sort of like that prison. And then when he walked away, like for the cameras, then someone pressed a button and it exploded behind him, crumbling in a matter of seconds, the same time as it takes a supernova to explode. So that is really good. I highly recommend it. And then, Space Encyclopedia. So, this is for a bit younger readers with a lot of amazing pictures. So this is the Crab Nebula, like I showed you earlier here. So, and it tells you about everything space. From a tour of the solar system to space hotels. And don't forget, there are links in the description below. And it is the end of another video. Make sure to subscribe and hit the notifications bell. And we actually have 2 jokes, but I think I already said them. One is the immense outward force that stops neutrons from touching their way of social distancing. And well, I ate a supernova. Astronomical transient event. And disclaimer, they were both made by me. That's why they're so good. But they were actually made by me. And like I just told you, there's more information in the links below. And remember, you are never too young to explore.